Hi, it's Miss Maison here. Thanks for tuning in. Today we're looking at elimination. It's one of three processes to solve a systems of equations, and this is from the grade 10 academic math curriculum, MPM 2D. So what do we understand when we hear elimination? It's a method of solving systems of equations. It's also called the addition method, and you're going to see that you're setting up your two systems of equations pretty much like a standard algorithm equation, and you're solving that way. To solve a system of equation by elimination, we transform the system such that one of the variables cancels out. So this is the key point about elimination, is that we're trying to cancel out one of the two variable terms so that we only have an equation with one variable in it, and it's easier to solve. Do you remember how to add and subtract polynomials? For example, if I were to give you the expression 2x plus 4y minus 3 in brackets plus 3x minus 3y plus 8 in brackets, would you be able to solve or simplify this expression? First things first, we would get rid of those brackets by expanding, but in this case we just have to drop it because everything is being multiplied by positive 1. We then just pair up our like terms, so collect our like terms. We'd have 2x plus 3x plus 4y minus 3y plus 8 minus 3. And thereafter, we would simplify each pair of like terms. So that's 5x plus y plus 5. Now what if, instead of collecting like terms horizontally, you collect like terms vertically? Remember when you used to do those standard addition or subtraction equations? It's the same idea here. So you're taking all of the values from the first bracket and stacking them on top of the second bracket. Be very mindful that your x's are on top of x's, your y's are on top of y's, and your constants are matching up with the constants of the second bracket. Add the two values together and you will get the same answer as we previously got in our last example, which is 5x plus y plus 5. This is the exact same strategy that we will use to solve a system of equations by elimination, except here we're going to eliminate one of the terms with a variable, and sometimes you'll be required to use multiplication to kind of manipulate the system of equation so that it has the opposite value found in the other system of equation. Let's have a look. So here we have 2x plus 8y plus 8 being one system of equation, and the second system of equation being 6x minus 8y plus 4. Now if you notice, first system of equation has a positive 8y, second system of equation has a negative 8y. So that means when we add these two systems together, we're going to end up with 8x plus 0y plus 12, which is simply put 8x plus 12. So now let's take a look at the 5 simple steps to solve a system of equation by elimination. Now step number 1, stack the equations as if to solve using standard algorithm or the old school way of addition. So mind the positioning of your variable terms and make sure that your y's are on top of y's, x's on x's, and constants on constants. Step number 2, decide which variable term can be canceled out. Now don't forget, you may be required to do some multiplication, but we will go through examples of each type of equation or pair of equations. Step number 3, you're going to just add those two equations together, eliminating one of the variables. Step number 4, now that you have an equation with one unknown, you'll be able to solve for the first variable. And step number 5, you're going to go back and substitute your solution for the first variable in one of the two equations so that you can solve for the second variable. All right, so let's give example number 1 a shot. So that's 3x minus y equals 5 and x plus y equals 3. Step number 1, we're going to stack our two equations on top of one another. We're lining up our x's, we're lining up our y's, and we're lining up our constants. Step number 2, this is where you're making a decision. You're trying to figure out which variable term can be eliminated. Here we're looking for opposite values. Here we have a negative y in the first equation and a positive y in the second equation. So the y variable is the one that I'm going to select to eliminate in step number 3 when I add my two equations together. So once I add them together, those y's cancel out, no more y's. 3x plus x is 4x, and 5 plus 3 is 8. Step number 4, now we're just using simple algebra. We're going to go ahead and divide out by the coefficient of x, which is 4. Once we divide that out, we will find the value of x being 2. Step number 5, finally, now that we know that x equals 2, we're going to select one of the two equations. I'm selecting the second equation, x plus y equals 3, and instead of x, I'm going to replace it with 2. I'm going to move the 2 over to the right-hand side of the equal sign, and I'll have y equals 3 minus 2, which is y equaling 1. Therefore, our point of intersection, or where these two systems of equations have the same x and y value, that's at 2 and 1. Now example number 2, that's x plus 5 equals negative 3y, and 4x minus y equals 6. Now off the bat, we notice that the pair of equations don't follow the exact same order of terms, but no biggie, we'll just rearrange one of the two equations. So step number 1, stack your equations one on top of the other. Ensure that your y's are lined up, your x's are lined up, and your constants are lined up. I'm going to go ahead and rearrange the first equation to match the order of the terms in the second equation. So my first equation now reads x plus 3y equals negative 5. Second equation, no changes there, 4x minus y equals 6. Step number 2, we're going to decide which of the two variable terms we are going to eliminate. Here we don't have opposite variables, so we just select one. We are going to eliminate the x value. We already have a positive 4x, so we need to create a negative 4x in the first equation. How do we do that? Multiplication. So we're going to multiply each term by negative 4, so that our new equation reads negative 4x minus 12y equals 20. And our second equation, again, no changes there, 4x minus y equals 6. Now we're ready to go because we have opposite values in our two equations. Step number 3, we're going to go ahead and add those two equations together, eliminating our x value and leaving us with negative 13y equaling 26. Step number 4 is nice and easy. We're going to use one-step algebra to solve by just dividing out the coefficient on both sides. So negative 13 divided by negative 13 and 26 divided by negative 13 to get the value of y, which is negative 2. Now that we've solved for one of the two unknowns, we can substitute negative 2 for our y value, and that's what step 5 is all about, substitution. We're going to take our first equation, substitute negative 2 for y, rearrange where needed, and simplify. So x equals 1. Therefore, our point of intersection is at 1 and negative 2. Moving on to example number 3, that's 2x minus 5y equals 11, and 2y plus 3x equals 7. Step number 1, stack your equations one on top of the other. Ensure your x's, y's, and constants are all lined up. First equation, no changes, 2x minus 5y equals 11. Second equation, rearrange to match the order of the terms in the first, and that will read 3x plus 2y equals 7. Step number 2, select one of the two variable terms to eliminate. Here, we notice that all our variables have coefficients, and no pair of coefficients are opposite values. So, we'll find the lowest common multiple between the pair of coefficients and make that our end goal. For this example, we are eliminating x, so between 2 and 3, the lowest common multiple is 6. What we'll start off with is our first equation, and multiply it by negative 3 to produce a negative 6 coefficient. For our second equation here, we're multiplying it by positive 2 to produce that positive 6 coefficient. So our new equations will read negative 6x plus 15y equals negative 33, and positive 6x plus 4y equals 14. We're good to go because we have our opposite values. Step number 3, add your two equations together. So the two equations that we produced in step 2, we're going to add those two together. And once we do that, we will eliminate our x value add our y's, add our constants to get 19y equaling negative 19. Step number 4, we will use algebra to solve for y. What does that mean? We divide out by the coefficient of y, and once we do that, we will have our y value equaling negative 1. Step number 5, we're going to use substitution. Now that we know what the value is for y, we take one of the two equations, substitute negative 1 for y, rearrange where needed so that we can collect our like terms, and simplify. Do a little bit of algebra here, dividing out by the coefficient of x to find the value of x, and x will equal 3. Therefore, our point of intersection between this system of equations is 3 and negative 1. So here are the basic skills that you need to succeed. You need to be able to do that polynomial addition when you're stacking your two equations on top of one another, using multiplication to your benefit to make sure that you have the opposite variable terms and you're able to eliminate one of them. You're going to use simple algebra to solve for your first variable and substitution, finally to solve for your second variable. And just like that, you've mastered solving systems of equations by elimination. Thanks for watching.